Hi guys, welcome to the interactive plotting exercise solution lecture. I hope you are already done with these exercises. However, as a part of this course, let's move on and go through these tasks together. So moving forward, the first task is run this cell to do some imports for offline interactive plotting. Let's run this cell, and now we are done with these imports. So the next one is again reading CSV file in HP. Let's run this cell. And now we have our word happiness data in HP. Let's move on and check the head of the data frame. So HP dot head and run this cell. And here we have the head of our data frame. Country, region, happiness rank, happiness score, and so many other columns. So the next one, call info on your data frame. HP dot info and run this cell. And here we have the same output. We have 157 entries and 13 columns. So if you notice, you have columns in the data frame that are float or int type. Use for loop along with .as type method to convert them to string. Hint is given. You can explore the lecture and find out how did we convert these columns from float to string. So let's move on and write a simple code. This is going to be a simple for loop. We are going to iterate over the columns in the data frame, and we can get columns with hp.columns. So for call in hp.columns, grab each column which is in call now, and hp convert that column to as type str. HP is going to give us the columns in our data frame, and we are using for loop to iterate over the columns and converting them to string type using as type method. Let's run this cell, and now we are done with this conversion. Let's check the data frame now. We can call info again on our data frame. So hp.info. If we run this cell, we see we don't have any column in float or int, whereas we had these columns in float and int. So moving forward, now our data frame is ready to create a text column. Recall the previous lecture where we created a text column from US exports dataset to summarize the volume of exports in a single column. In this case, we are using country, happiness rank, happiness score, freedom, generosity, and trust to create a text column with the information from all of these columns. The code is given, you just need to rerun this cell. So this is the new column text. We are grabbing country column from the data frame, and then we are grabbing happiness rank, happiness score, freedom, generosity, and trust column. Let's run this cell, and moving forward, let's check the head of the data frame again to see if we got the new column in our data frame. So hp.head and run this cell. We see we have a new column text which has country name, happiness rank, 1, happiness score, and so on. So we got the new column in our data frame. The next one he's asking for, create line plot for happiness rank versus health, freedom, and trust. So let's create a plot now. Once again, a simple interactive plotting using Plotly is very simple. You just need to call iPlot and pass in the kind parameter to tell the Plotly what type of plot you want in the output. So HP is our data frame, call iPlot on the data frame, and then our X is going to be happiness rank and Y is going to be the list of these columns. So X equal to happiness rank. Just to save some typing, we can copy this from the data frame above, like this one. Happiness rank, and then our Y is going to be list of all these columns: health, freedom, and trust. So health is this one, freedom is this one here, and then trust, government corruption. So the third column is trust, this one here. It's easier to copy from the column names. You can save some typing and there are less chances for the typo error as well. So the next thing is X title and Y title along with the title for the plot. We can set the X title using X with capital T title and pass in the title happiness rank. Our Y title with capital T is index, and the title for the plot is simply title with small t. 2016 happiness rank versus generosity, freedom, trust. So we are all set for the plot. We are calling iPlot on our data frame, grabbing X as a happiness column, Y list of the columns we want on the plot, Y title is happiness rank, X title is index, and the title for the plot is 2016 happiness rank versus generosity, freedom, and trust. Let's run this cell. And here we got our interactive plot. And you know you can always deactivate or remove any data from your plot with a single click. And you can active them again or put them on the plot once again with a single click in this interactive plot. So next one is recreate the plot below. Hint is kind equal to bar. So this one is a bar plot. Very simple to the previous plot. The difference here is you're going to pass kind equal to bar. X title is country, Y title is trust on the government. There is a title for the plot as well. So let's write a code for this one. hp.iplot pass in kind equal to bar, and then X is our country. Y is going to be trust. Let's move back and copy this column name so that we don't really get any error at the end. So this is the column here. Copy this one and paste it here. Let's set the title. X title is country. Our Y title is trust on the government. And the title for the plot is going to be 2016 happiness rank country versus trust on the GOVT. So our kind is bar, X is country, Y is the trust, X title we are setting to country, Y title is trust on the government, and the title for the plot is 2016 happiness rank country versus trust on the government. So let's run this cell. And here we have the same plot. We have title for the plot, we have trust on the government along y-axis, and the countries along x-axis. One thing you may notice, in this plot we needed to pass the bar, whereas in the previous plot we didn't pass anything in the kind. So by default the kind is line plot. So when we are not working with the line plot, we have to pass in the kind parameter, like we passed in bar here. So moving forward to the next question, create a choropleth for happiness score that displays the data from the newly generated text column when hover. So you need to create a data dictionary and the layout dictionary. You can either copy the code from the Plotly cheat sheet or from the lecture notes. I'm not going to copy the code from there. Let's move on and write the code here. So data is going to be our data dictionary. If you recall the lecture notes or from the Plotly cheat sheet, the first thing we pass in type. So what type of plot we want? We want choropleth. Then we need to pass in the locations. So locations is our HP, and we have country column. We need to tell Plotly the location modes as well. Location modes, and in this case we have country names. You can explore the Plotly's documentation and learn more about the location modes and all other parameters. You have options to pass in the location modes and other parameters as well. So in this case we need to pass in country names. The next one is Z parameter, and let's pass in HP and grab the happiness score. So we want happiness score in our scale bar as well. So the next one is a text column that we have created. Text is HP and grab the text column. Moving forward, color bar and title of the color bar, which is happiness score. So this is a dictionary again. Let's move on and create a layout dictionary. Layout. So our layout dictionary is going to be title, because we have title here, happiness score. And the second thing we need to pass in geo, and the geo is going to be another dictionary, and we need to pass in projection here. This projection is Mercator. You can play with other projections as well. So let's pass in Mercator at the moment. So projection is another dictionary with type of the projection Mercator. So here we have our layout dictionary. So let's go through this code once again. So data is going to be our data dictionary. So this should be dict, and then type we are telling we need a choropleth. Location is HP, our country column. We are telling Plotly that location modes is country names. Z is happiness score. Text is the column that we created, and color bar is title happiness score. So this should be dictionary as well. So it's not list. So the rechecking of the code is always helpful. You will get things done before you run the code. So the layout dictionary is dictionary. Once again, this should be dict, and title happiness score, geo, and once again this is dict. So projection is Mercator. Let's run this cell. There's an error here. Let's see what is the error here. So this should be location mode instead of location modes. Let's rerun this cell, and here we have the map. We see we have the similar plot. When we hover our cursor on the map, we see some text that is from the text column. Happiness score is there, happiness score along the bar as well. So if we compare, we have some difference here. The one thing is color scale is not same, and the other one is we don't have any frame around this map. So we need to work with this frame option and the color scale. So this color scale is actually Portland. You can try different color scales as well. And let's move on and set the color scale. So color scale is Portland. And let's rerun this cell. And here we have the similar color scale. We got the same color scale actually now. And now let's work with this frame. The frame can be turned off and on. By default, it's true. So we don't want the frame in our map. We can go to the layout dictionary and pass in show frame equal to false in geo. By default, it is true. So show frame is equal to false. And then now Plotly knows that we don't want frame around our map. Let's rerun this cell, and here we have the same output. If we move cursor on the map, we see the text appearing, which is in the text column. We have the scale on happiness score, and so on. Let me introduce another parameter here, which is not really required. For the scale, you can pass in reverse scale true. If you pass in reverse scale true and run this cell, you will see you are getting the scales in the reversed order. However, it is not required in this exercise. But still, it's good to know how the color scale can be reversed. The map looks different, and now it's much more clearer that dark blue and blue are the countries that are on the happier end. So moving forward to the next question. For the US election data, import the dataset first. Let's move on and import the dataset. USDF pd.read CSV and pass in the file name. If you have file in your working directory, you press tab and it will be auto-completed. Let's run this cell and move on to check the head of the data frame. USDF.head and run this cell. And here we have the head of the data frame. Year, state, and so on, voting eligible population, and a couple of other columns. Let's move on for the next question. Recreate the plot below. Kind is bar, X is state, and Y is voting age population. So you have to recreate this plot. This is very simple plot. No title is required. There is no X title, Y title, or the title of the plot. So simply you need to grab the data frame USDF, call iPlot on the data frame, and then pass in kind equal to bar, and your X is going to be state, and your Y is going to be voting age population. Let's copy this from here and run this cell. And here we have the same plot. So moving forward, the next one is now create a plot that displays the voting age population per state. If you later want to play around with other columns, make sure you consider their data types. Anyhow, let's move on and create data dictionary and layout dictionary. The hint is in the marker, which is in the data dictionary, set the line color to white and its thickness to 2 between the states. Like we need this line between the states, which is a white line here. And then set show lakes equal to true in layout. We want these lakes in our plot as well. So let's move on and create a data dictionary for the US level choropleth. If you recall the previous lecture, you have already created similar stuff there. So data is going to be dict, and let's pass in the type, which is choropleth, and our location USDF. Grab the state abbreviation column, so this column here, state abbreviation. Let's paste it here and then move on towards the location mode. So our location mode is US states, USA states. You can explore the plot list documentation to all types of available options for these parameters. And our Z is going to be USDF, and we want voting age population. Voting age population VAP. The next one is we want text, which is name of the state. Notice that you have California here, you have Texas, and so on. So we want text as USDF and the state. The hint he is giving, we want these white lines between the states, and we need to set marker here. So let's pass in marker, which is dictionary, if you remember from the previous lecture, and line is another dictionary that we want to pass in color and set the color code. Let's set the RGB 255, 255, and 255, which is the color code for white color, and then width of the line is 2. So moving forward, another thing is the color bar. So the color bar title is voting age population. So we need to set color bar and then its title. Title is going to be voting age population VAP. Now the next one is layout dictionary. So layout DICT is a dictionary. Title, so this is the title of the map. So title is going to be 2012 general election voting data. So let's put it in the quotes. And the next thing is geo, which is a dictionary again. So the scope is USA because we want only United States map. And then another thing we notice, he's asking to put the lakes here as well. So we need to set lakes as well. So show lakes equal to true. And then lake color is blue. If you remember from the previous lecture, we can pass in the color code for the blue color as well. So lake color equal to RGB, and the code for the blue color is 85.173.240. You can Google it or you can copy this code from the lecture note. So let's go through this code once again so that we can avoid as many errors as possible. So in our data dictionary, we have data equal to dictionary dict, and we are passing type equal to choropleth. We are setting locations to USD states abbreviation. Location mode is USA states. Z is our voting age population. Text, we want the name of the state. Marker, we are setting a nested dictionary to keep a line between the states, and we want that line of white color with its width equal to 2. And the color bar title, we are setting voting age population. I hope this is all good to go. Let's check the layout here. Another dictionary, the title for the map we are setting, which is here. In geo, we are telling the scope, we want US map only. Show lakes is true, we want the lakes on the map. Lake color, we are setting blue. And then this is code for plotting. It looks like we are good to go, but still I would go back and copy this column name from the data frame so that if there's any space or anything, we can keep the same thing as is. So copy this one, paste it here. Yeah, I think we had some error here as well. And run this cell. And here we have the map, and this is what he was asking for. Let's play with this line and see how the thickness works. If we set line to say 10 and rerun this code, look at that one, the lines are much thicker. It doesn't look nice, so we have to pass in some reasonable value. So the 2 is quite good. And here we have, oh, we passed in 20. So 2 is quite good. And let's run this cell. And this is the same map again. The lake color is blue. And if we move the cursor on the plot, we see California 28.91 million, and then Texas, and then New York, and so on. So this is our required United States level choropleth. Once again, I want to mention that this is hard to remember this code. You can always copy this code from the Plotly cheat sheet and make some changes according to the requirement. So moving forward to the next one, which is regarding the alcohol consumption by country, and he's asking to read the dataset again. Should be very simple. So df is going to be pd dot read underscore csv and pass in the name of the file. If we have file in the folder, and if we type 210 underscore and press tab, it's going to be auto completed. So we have file in the folder, we don't need to type this complete name. Let's run this cell, and we have data in the data frame df. Let's check the head of the data frame and run this cell, and here we have the head of our data frame. We have 2 columns, location and alcohol consumption. Moving forward, recreate the bar plot below. This is again the same bar plot. You have country along x-axis and alcohol consumption along y-axis. X title you need to set, Y title you need to set, kind is bar, and the title for the plot. I hope it should be very simple for you now. So df.iplot and pass in kind equal to bar. I just like to write code on the next line. If you want, you can write all these codes and everything in the same line as well. However, I recommend to write the code in separate lines. It can take some extra space, but it's easier to go through this code once you get an error. So kind is bar, our x is going to be country name, which is actually location. Let's copy this column just to save some typing and to avoid any typing error. So y is going to be our second column, which is alcohol. Once again, we copied from the data frame just to avoid any typing error. We need to set x and y titles as well, and the title of the plot. So x title, this is with capital T title. So this is extra T here, let's delete it. Title is going to be country name, and our y title is alcohol consumption arbitrary units, and this is what the title is. And the title of the plot is alcohol consumption by country 2010. This is with capital C. Let's have a quick look on the code. df.iplot, we are passing kind equal to bar. We are grabbing x as a location, y alcohol, so it should be L as well. X title, Y title, and the title of the bar plot. Let's run this cell, and here we have the same output. We have alcohol consumption by country 2010. So if you move the cursor on the plot, you see the country name and the alcohol consumption. Like Belarus 17.5, and then Russia 15.1, and so on. Belgium 11, and Switzerland 5.7, and so on. So the next one is, he's saying this plot is not great for such data. You may want to create a geographical plot. Once again, he's asking for choropleth, which is a word level of choropleth, and you have to recreate this plot. You have alcohol consumption as a bar title, you have the title for the plot, and a projection that you need to create the same one. Note the frame around this plot as well. So let's move on and write the data dictionary once again. I'm not going to copy this data dictionary once again because I want you to do practice as much as possible. So let's create a data dictionary. Data is going to be DICT is a dictionary, and then the first thing I hope you can lead me through, type is choropleth, and then locations, grab df and location column. Let's copy this location from here and paste it here. The next one is location mode, which is once again country name. So country names. Then we need to pass in Z. Let's grab DF, the alcohol consumption. So ALCOHOL, alcohol. Text, we want the name of the country again. So DF. We can recheck, like if you hover your cursor on the map, you see Canada and some numbers. So this number is alcohol consumption and Canada is the name of the country. So the text column, we want the country name. Text is DF location, and location column contains the country name. The last one, we want the color bar title, which is alcohol consumption. So let's pass in color bar and its title alcohol consumption. So let's put it in the quotes. Let's move on with the layout dictionary. So layout is equal to, so layout is going to be dictionary, and then we want title of the plot. Title is going to be 2010 alcohol consumption. So let's put it in the quotes. You can use single or double quotes, anything, it's your choice. So the geo is going to be projection, and just want to tell you guys, the projection type here is Robinson. So you can try different projection like Nature Earth, Miller, Mercator, and so on. This projection, what he's asking in the output, is the Robinson projection. So let's delete this hash so that we get the output. Let's have a quick overview on this code once again so that we don't get error when we run this cell. In our data dictionary, we are setting type is a choropleth. Locations, we are grabbing df location column. Location mode is country name. For Z, we are grabbing alcohol column. Text is location, the name of the countries we are grabbing here. Color bar is title alcohol consumption. And moving forward to the layout dictionary, where we are setting title 2010 alcohol consumption, and then geo, this should be dictionary again, DICT, and then projection, we are setting Robinson. And let's run this cell, and it's giving an error. So this should not be in the quotes. Let's rerun this cell, and here we have the similar plot, but the color scale is different. This color scale is viridis. So let's pass in the color scale here as well. So color scale is VIRIDIS. And let's rerun this cell. And here we have the viridis color scale. So once again, if you notice that the color scale is in reverse order. So our color scale is in reverse order to the color scale what he is asking for. So we need to pass in other parameter here. So we need to set reverse scale true. So now We are setting color scale to viridis and then setting it to true as a reverse scale. And let's rerun this cell. And here we have the same output. So this is the same output what he was asking for. Let's do another thing here, which is not required, but let's pass in show frame equal to false in geo and rerun this cell. Notice that you are not getting the frame around the map. So the only difference is now the map don't have this frame. So you can play with all these different kind of parameters. You can explore the Plotly documentation for choropleth to learn more about the possible options for all the parameters. Let's run this cell again to get the same output. So now we have the same output for our map. If you hover on the map, you see numbers and the name of the country and so on. So guys, this was all about the interactive and geographical plotting project solution lecture. I hope you enjoyed this lecture. Once again, there is a possibility when you are working with the choropleths and you get error in the code. This is little complicated, and I suggest if you are writing this code, go through this code once again and see if there is an error. If you get error, just fix that code and move on. You don't need to memorize, copy and paste it and do changes according to your requirement. So moving forward, I want to say that I am really impressed with your progress. Keep your spirits high. You are moving forward to the machine learning section. However, before that, we will work on the capstone project. So see you in the next lecture. Good luck.